Hi everyone, welcome to today's SIG scheduling meeting. Last meeting was canceled due to the CupCon, so this is the meeting for June 2nd. Okay. And there's not much items in the agenda, so the first one is the delete bonding proposal. This is a very old issue back in 2015. So the background is that in the very beginning, we don't have a clear GVK group version concept. So a lot of resources were defined in the top level, like the bonding resources. So the bonding is an operation to ask the API server to modify the path spec.name, as you may already know, but it's now a top API, which is on the V1, but that semantically doesn't make sense. So the proposal is to make it on the path, so that is path/binding. So that can distinguish each resource bindings request separately. So the proposal makes sense to me, totally makes sense to me. And yeah, it seems somebody already had did some investigation. So if possible, I may request some of them to get them implemented, or some of you in the meeting are interested.
Sorry, it's not clear to me if the pods/binding endpoint already exists. Does it?
I think the v1.binding is right now only used by scheduler. And so if we turn to path/binding, that should be the things, the migration things we should do. And then need to check with API folks, see how soon we can totally delete the v1.binding resource.
I see. Well, it sounds like something that would require a cap, probably.
Yeah, I think so. Yeah.
But who is requesting this? Why is it important?
Because semantically, the v1.binding means to bind a path. That doesn't semantically match its semantics, right? So the binding in the top level, well, is not that suitable. So if you look at some other patterns, like there's some other external project says, okay, I want to do a binding to my resources, like, so they need to implement the specific resources/binding instead of get confused by the top level v1.binding. So what does that mean? That actually means the path binding. So that doesn't quite look clear to them. So it's just to make the semantics more explicit and clear. And also I did a quick search and I can confirm, at least in Kubernetes/Kubernetes, only the scheduler is using the v1.binding.
I see. Oh yeah, I don't have anything against it. I'm just not sure about the priority.
The priority, yeah, given it has been existing for a while, it's not that urgent, and it's just a good to have to get implemented and get the semantics more clear.
Yeah, but I think it is not only used by the Kubernetes. It also may be used by some people user-defined custom scheduler. They also use this binding API to update the node name of the pod. Yeah, but if we change it as the API level, it may be hard for the people to integrate with the Kubernetes. They may be updated. They maybe need to update their product, to integrate with it.
Either they are studying from scratch to build a scheduler, so they implement their own bonding logic, or they're using the scheduling framework to implement a bond plugin and they use the same way as the core scheduler to do the bonding. So yeah, that's a valid point to consider why if we decided to get that implemented.
Yeah.
So basically, it's this. It's a polishment, but it may have some side effects. So I'm not sure if we put that as into the SIG architecture or SIG APM machinery, that will get some pushback. And the same, so we don't have much benefit, except for making the things more pretty, more clean. So yeah, it depends. It depends on, maybe there's some API also API implications out there. So yeah, this is the thing. I will comment on the issues to see who is interested and who may already have some expertise and do some research on this. Right, this one. And other than that, it seems there's no other items today. And if you do have some, please raise it up. And otherwise, I may give you some minutes back. And Aldo, do you see any urgent items to discuss today?
Sorry, I didn't hear properly.
So I mean, do you have any urgent items in your mind to discuss today?
No, well, since we have time, maybe we can chat a little bit about the one I just posted in the chat. The one about events to register.
Mm-hmm.
I think you already had a quick look at it.
Yeah. Yeah, I haven't got time to follow up on this, but that is a good issue to discuss. Let me link this to get more attention from people. Or if you can add it, and if you have that link around, you can paste it into the Google Doc. Yeah, so this issue is that so along with the introduction of the events to register function, so each plugin can claim what kind of cluster events is correlated with the failure that this plugin fail particular paths. Like if you are volume bonding plugin, so you fail a path by register some volume events. Like if a new PV or PVC get introduced, maybe the unscheduled path failed by your volume binding plugin can be made reschedulable. So this is good. But there's some corner cases, not corner cases, but some special cases is that like the Sambashiho mentioned that there's some categories we didn't consider properly. And yeah, if you want to look at, just look at this comment. I won't go through every case he mentioned because some of them are still being discussed. But some of the point is valid, like this one. So, for example, if pod failed by some advanced scheduling feature, by advanced I mean some features that consider cross-node pod distributions, like pod topology spread and the interpod affinity. So in this case, you cannot simply think that a single pod's event will or will not impact this pod's reschedulability. So this is a thing we didn't consider properly. And nowadays, like for now, if a pod get added, for example, maybe the node you previous failed, I mean, not fit for the pod topology spread can be schedulable because in another pod, in another node, the total number of that particular node, of that particular topology region get increased. But right now it's not implemented yet. So this is totally one thing we should consider. But another angle to look at this problem is that some of the design, especially the interpod constraint, make this design more complicated. Like even some, I will say, call it mixing scheduler directives. Like in the latest implementation of the pod topology spread, we introduced the minimum domains. We introduced the nodes inclusion policy. So that is totally one area we need to consider when we actually mixing some scheduling features all together. So this is I will go through the comments today or this week and see whether we can get a good strategy on this. And this is the background of this issue.
So I guess to summarize today, let's say when a node changes or a node is added, we check if that passes the node affinity and things, right?
Yeah, that's
before putting a pod back.
Yeah.
But I think the problem here is that if that node cannot have the pod, it doesn't mean that the pod wouldn't fit in other nodes, existing nodes, because this node change, right? That's the problem.
So I think the pre-check will fit for the regular scheduling failures. I mean, the single node check scheduling failures like resources, like no pod, like some others. But for the interpod scheduling constraint, like if a pod previously failed for the pod topology spread and a new node get added, for example, if a node get edited, like its label got changed, definitely it's a potential event that can make the pod which failed the pod topology spread reschedulable. So that is the thing we didn't consider.
I think the point is that it might be schedulable not in this pod, not in this node that is changing, but in other nodes, right?
Yeah. So this event can make other nodes, can make the pod fit in other nodes. Yes, that's correct. So it's like a cascading event. It's not singly on this particular node, right? It's a cascading to make other nodes schedulable.
So what would be, do you have any idea of how the high level solution is? Is it?
I need to thoroughly think about it. So in my mind, I even want to separate the schedule directive or schedule constraint into two top level categories. One is basic scheduling constraint, which is fit for the one node, right? And the other is more advanced features, which is to consider cross-node distributions. So for pod topology spread and interpod affinity, that I think is the most special two features we have now. So for these two features, we need to do some additional check to see, okay, if the node doesn't, for example, if a node get introduced and then we iterated the paths, right? If a path doesn't go through the pre-check, but it's a particular path failed by the advanced scheduling plugins like pod topology spread and the interpod affinity, we still get it a chance to be moved back. So that's a very rough idea I have. So each plugin maybe have a attribute to claim it as an advanced scheduling plugin or a basic. So for basic, we just do the pre-check basic check. And for the others, we give it a chance. But it's very rough. Yeah.
Did we find a case for pod affinity or anti-affinity? Because for, if I remember correctly, for pod affinity, when a pod changes, we check that if it matches the anti-affinity or affinity.
In terms of interpod affinity.
Yes. So my question is did we find a case where that's not enough? Because I'm convinced that there is a problem with topology spreading, but I'm not convinced there is a problem with pod anti-affinity, pod affinity or anti-affinity.
I can think of it. So pod anti-affinity, maybe there's no such cases. For pod affinity,
so I guess the point is that a pod is immutable, right? So
yeah, pod is immutable. Yeah,
including labels. Yeah, labels are immutable as well, right?
it seems pod affinity, we don't need to consider that. Only pod topology spread is the only corner case. But no worries. Let me think about it thoroughly offline.
Then I guess my question is whether we want to make it configurable or make it only for pod topology spreading.
Yeah, that's a good question. There should be some trade-off to whether make it configurable, but the downside is more complicated for user to understand and implement. If we make it sort of hard-coded, it will be simple for users, but not extensible. Yeah, but there's some trade-offs we need to consider.
But I think Alex might know this, but the co-scheduling plugin has this problem too, right? About new pods being added. Is that true?
Yes. So for co-scheduling plugin, the use case is that one pod arrives to mark the completion of a pod group. So there's a enhancement is that particular, we can call that pod a critical, the pod in the critical path to mark the finish of the pod group. I mean, satisfy the minimum member of that pod group. So upon the arrival of that pod, and that pod happens to be schedulable, we initiate, activate a request in that pod scheduling process so that it got the chance to, during that pod's waiting period, that the other n-1 pods get the chance to be moved back to the active queue. So that's the technique the co-scheduling plugin is doing. Like it's activating, it's proactively activate its siblings of that which belongs to the same pod group. So that's the.
Oh, I see. So through this API, this plugin is able to.
It's more a hook in the framework because it's using a public defined and reserved the key, the string called the path to active, and in the skeleton of the framework code, we will check that by the end of scheduling cycle and the binding cycle. So if we got some paths in the state, we will move them back in a best efforts manner. That's a more hook instead of public SDK API or APIs. Yeah, its goal is to make the pods belonging to the same pod group has the higher chance to be diverged one by one and to be rescheduled. So you can see it's for the performance, to improve performance, and got kind of confirmed by some users like the OpenAI. So for now, I'm maybe more inclined to just mark the pod spread as an exception and do some particular logic out there. Unless we want to have a good extension in day one.
So I think that the somewhat good thing is that it only applies to pods that use the require spreading, right? The do not schedule.
Yeah. The hard requirement.
Which is not a very popular feature. So if someone wants to enforce it, I guess it's acceptable to decrease performance, because when we're retrying pod scheduling, that slows down the cluster autoscaler. Because when you try to reschedule the same pod, that means that newer pods are not getting marked as unschedulable, which is the information that the autoscaler needs to to start scaling up if necessary.
Yeah, so nowadays, does autoscaler ignore the events of path scheduling if that pod failed for the path topology spread?
So the cluster autoscaler waits for a pod to have an unscalable status before doing anything with this pod.
Yeah. Yeah, because the autoscaler needs to get more concrete information to know how many and what kind of nodes to provision to satisfy the pod, right?
It's somewhat, it's to prevent the autoscaler from scaling up too early before, before the scaler had a chance to say something about the pod.
All right, I think that's basically the big picture of this issue. Oh, one other thing is that we may promote the scheduler component config to V1 in this release in 1.25. If there's an issue, then I will link it back here. If there's no objection, we will follow that path. And there's a discussion is to keep the V1 beta 2 still for another release, but mark it as deprecated. Let me find the issue. Well, doesn't have that around. I will place it back here. All right. Do you have any other items to discuss? If not, I will stop sharing and give you 15 minutes back. And I will see you in 2 weeks. Thank you for joining today's meeting.
Thank you.
Bye.
Bye.